Welcome to the Curiosity Crisis. This podcast isn't about topics. It's about an approach. We take eclectic, timeless ideas and distill them into clear commute-length episodes. Designed to help you practice the art of curiosity, this show is for curious minds navigating a busy world.
Kirsten Banks, also known as Kirsten, is an astrophysicist and science communicator passionate about making the universe accessible to everyone. A proud Wiradjuri woman, her work spans research in galaxy evolution, radio astronomy, alongside a growing presence in public science education, breaking down complex cosmic ideas into engaging, relatable stories. Through her work, Kirsten brings a fresh perspective to both the science itself and how we connect with it. And we're incredibly excited to have Dr. Kirsten Banks here with us today.
Good to be here. I'm excited to spread the curiosity, as it were.
Thanks so much for joining. And we have a very simple question that we ask all of our guests, Kirsten. So I hope you're ready, which is, what's keeping you curious at the moment?
Well, what's keeping me curious at the moment is I have a current obsession with one particular object in the night sky, and it's called the Crab Nebula. This thing has been something that I've enjoyed looking at and look at the photos taken by the Hubble Space Telescope, for example, even with the James Webb Space Telescope as well. But recently I've been obsessed with its history. Chinese astronomers 1,000 years ago saw it appear in the night sky when the star that came before it exploded. And then the history of who has seen it beyond that moment and piecing together all the information from each observation is keeping me curious every single day at the moment. I love it.
I actually saw that was in your 2025 recap of Astrophysics, and I saw that that was in there. And what blew my mind, it's something that I just never considered before, was that there were Chinese astronomers so long ago. I just never thought of that.
Yeah. There have been many astronomers for thousands of years in different cultures around the world. And even within Australia as well, we've got Indigenous astronomers that have been looking up at the stars for tens of thousands of years.
What is define to me an astronomer? Are we astronomers, or is it somebody with a sort of a specific keen interest, or
Yeah, I guess it depends on the lens that you look at it with.
Yeah.
If you look at it from a, tertiary education Western lens, it's someone who is studying and researching the universe. Mm-hmm. Although it can get a little bit dicey, and this is kind of fun. I deal a little bit of drama. Sometimes people will argue what is an astronomer and what is an astrophysicist. And it can be a little bit interesting depending on who you ask. An astronomer could be someone who is looking up at the stars, taking photos of the sky, doing astrophotography, and understanding the sky as it is and how we see it. Mm-hmm. Whereas an astrophysicist goes a little bit beyond what we see with our eyes, using telescopes to see further outside of the Milky Way galaxy and understand the physics of the universe.
Okay.
But when it comes to a cultural lens, though, it's someone who is kind of similar to an astronomer, where you're looking at the sky, but you're taking meaning from the night sky. Mm-hmm. And from an Indigenous and First Nations lens, for example, that's looking at that knowledge and looking at the night sky and using it as a canvas for our stories that intertwines so many other different facets of life. It's all intertwined, and it's the epitome of interdisciplinary research.
Yeah, wow. Okay, that's really, really awesome. So
I'm sure the first humans were looking up at stars. So, yeah.
Absolutely. It's just right there. You just look up. It's so accessible. And I love that part of it.
I think one of my favorite national parks to visit is the Warrumbungles. And it's because it's I think supposed to be one of the premier stargazing and I guess astronomer parks, because it's so dark and it's just got amazing stars. So getting there, I love it. But I imagine doing that from thousands of years ago when there were no city lights and stuff like that to impede it. Yeah.
The Warrumbungle National Park, it is a dark sky preserve. So it is a dedicated dark sky site.
Yeah, wow.
Where there are certain regulations for the towns and the cities surrounding this area, where lights can only be a certain color hue, or they only have to point downwards, and they have to turn off at a certain time. Because there's also a telescope and an observatory up on Siding Spring Hill. So Siding Spring Observatory is up there, right there within the Warrumbungle National Park. Fun fact, like you mentioned that the sky looks great there, and it does. But you mentioned that you want to go back to a time where there's no light pollution at all, because from that position on top of Siding Spring Observatory, you look around to the entire horizon around you. And if you look towards the southeast, you can actually still see the glow of Sydney.
Oh, wow. Oh, really?
Really?
Yeah. So imagine, with nothing there at all, like that would be incredible, especially from vantage points like that.
Yeah.
Okay. There you go.
That also goes to show how bright our cities are, really, doesn't it? Yeah, that's
Should
great.
change that as much as we can.
So diving straight back, right back into your story, how did you first get drawn into astronomy and then astrophysics? And what keeps you super curious now?
Yeah, so there was one moment that I remember that sparked my curiosity, and it was in about year 10. My science teachers, they took my entire year group on an excursion to see a documentary about the Hubble Space Telescope. And we were watching this documentary, and there was a scene where you had a fly through of the Orion Nebula, which I actually have a picture of it behind me here. You have a fly through of the Orion Nebula, and I was just so enthralled by how much information we can learn about something so far away just by looking at the light that it emits and the light it doesn't emit as well. And I was like, yep, I want to be an astrophysicist. And so I went on and did a bachelor's of science majoring in physics, an honors year in astrophysics where I studied galaxies and how they grow by consuming their neighbors. I wanted to call my thesis A Tale of Galactic Cannibalism, but my supervisor said no, unfortunately. And then I went on to study the history of the Milky Way galaxy in my PhD.
Wow.
And
That's unreal.
The thing that keeps me curious every single day is just the mysteries of the universe, because there are so many of them.
We actually have a question about that a bit later. I have a quick question about that, which is, look, to be completely transparent, Kush and I don't know a lot about astrophysicists. And we were wondering if you could kind of walk us through what the day-to-day of an astrophysicist actually is.
Absolutely. I'll take you back to some of the most intense research times of my career, and that was during my PhD. Mm-hmm. And now a day in the life of an astrophysicist really depended on whether I was working actually during the day or during the night, because it could go either way depending on what I was doing. A typical day that I had actually working during the day, I would get up and basically be on my computer all day, coding, doing mathematics, running models, and trying to understand the data that I was studying and researching, and probably reading a few papers here and there, having coffee and chatting with the other researchers and other PhD students. And that's basically what those days look like, is trying to understand the universe using my computer and coding. But sometimes I would work during the night, and that would be when I'd be observing with those big telescopes. I actually used the large telescope, the Anglo-Australian telescope, on top of Siding Spring Observatory during my PhD. I collected my own data. But that was during the time of COVID lockdowns, and so I couldn't go to the telescope, and did all of my observing from home, basically.
Oh my God.
So I would wake up at 2 p.m. rather. My day would start at 2 p.m., have breakfast, and then stay awake all night until the sun came up the next morning, and then went to bed. So during that day of work, I would be making sure the telescope is working well, avoiding clouds if it's a cloudy night, and observing stars. And while observing stars, watching a little bit of Netflix, because as long as the telescope's doing its thing, there's a lot of downtime just waiting for the next observation to start. Because you could be looking at a star for 20 minutes at minimum, an hour at maximum.
Okay.
Were you trying to observe the same celestial objects consistently, like every night, or were you switching? Were you just like looking at what was available? Like you said that you were dodging clouds. Were you? I guess just trying to understand that. Yeah.
Yeah. So with my particular research that I did, I was trying to collect data from specific types of stars. So as soon as I got good enough data for one star, I'd move on to the next and just try and get more and more and more to build up my sample of stars. So I ended up with, I think, 300 stars in the end to work with, which is a relatively small data set when it comes to astronomy. There are new telescopes out there that are capturing 20 terabytes of data a night.
Wow. Oh my God.
It's incredibly awesome. But
Big server.
thankfully, I only had 300 stars to deal with, and my computer only on occasion sounded like it was about to take off into space.
That's nuts.
Wait, did I mistake it? Were you controlling that telescope from like remotely to watch the stars?
Basically, yes. So there would be someone at the telescope, the night assistant, who would be doing more of the analog things, making sure it's physically working well. Then the program and the instrument that I was working with, you could basically just queue up different tasks for the telescope to do, and it would just follow those tasks without any worry.
Yeah, wow.
Hence the Netflix, because you would just be kind of waiting, making sure, did it do anything? And they call back to my show.
Nice.
That's amazing.
I mean, that's, and I guess as an astrophysicist, I don't even know if you can call that night shift. Like, you know how like people work on site and they sometimes have night shift and it's a real change up. But if that's like your natural, like if that's your subject of study, does that even count as like night shift, or is that just regular hours of work? Because
that's day shift.
Yeah. It's basically the same as what you would do during the day, somewhat, but it definitely takes a toll when you're like, 2 p.m. to 7 a.m. basically was my awake time, and I had to be asleep to just function otherwise. But it was very cool. The time that I had during 2021 when I was observing from home was right when the lockdowns went to the whole state. And what usually happens with the telescope is that there are different instruments that you can use on the telescope, and they can literally swap over the top end of the telescope depending on what you want to use. But with the lockdowns, they couldn't get people in to safely change over the telescope instrument. So I got some more time and ended up doing night shift for 2 weeks.
Oh, wow.
In one stint.
Oh, my God.
Wow.
Never again. Do it, guys. It's not fun.
That's so lonely task.
That is
The one thing that got me through that was my partner, whenever I woke up at 2 p.m., he'd be like, "Good morning." Like, thank you. I do appreciate that, even though it's very much into the middle of the day for you.
A nice wake up every day.
Yeah.
Oh, that's cute. Okay, so changing gears, but just going deep, like, or not super deep, because I guess you're the perfect guest on the show because you're super curious, but then also you're a science communicator, so you're part of your day to day is distilling crazy topics, like crazy complex topics into digestible bits for non-scientists. So if you had to pick one, what would be your favorite, maybe current topic or concept in astrophysics, and explain it to a 7 or 8 year old?
Ooh, I think my favorite thing to explain to 7 or 8 year olds is always going to be the concept of spaghettification. So when you're traveling towards a black hole, say you're traveling feet first towards a black hole, specifically a black hole that's been created by a star dying at the end of its life. So if you're going feet first, the gravity that pulls on your feet is much stronger than the gravity that pulls on your head. And so as you fall towards a black hole, you get strung out like a long piece of spaghetti, hence spaghettification. And I think that's always just such a fun, terrifying thing to talk about when it comes to 7 or 8 year olds. Like, they just love that sort of stuff. And I have a story. I was explaining this when I was a tour guide at Sydney Observatory back in my undergrad days. And I'd finished my explanation about spaghettification. And this young girl, probably about 6 years old, shoots up her hand and she says, "So would the blood be the source?" That question has stayed with me for like 10 years now. I agree, yep, the blood would technically be the source, but oh my goodness.
That's such a quick response for a child as well.
Yeah. Tied up. I'm like, oh my God, I was so excited. Like, oh, look, you're so curious. You have a question. Let's go for it. And then nightmares after that.
Oh, that's the best response you could get.
That's unreal.
I have another question. So is there something that people, they think they understand about space, but it's a misconception, or they always get wrong? Because I feel like our knowledge of space is always, it's just moves so fast. I mean, I did astrophysics in year 12 for one of my subjects in physics. And, we learn a bunch of stuff, but I know very well that there would be all kinds of things that have changed probably since then.
Yes, there are a few things that have evolved since then with our understanding of the universe. I think one that has come to mind recently, because someone left a comment on this on one of my videos recently, and it's the idea that black holes at the centers of galaxies are what holds galaxies together. And that's not quite the case. So black holes, supermassive black holes, they are, as the name suggests, supermassive. And so they have a lot of mass. But when you compare the mass of, say, the supermassive black hole at the center of the Milky Way to the mass of the Milky Way in its entirety, the mass of the black hole is just 0.0003% the mass of the entire galaxy.
Wow.
It's nothing. Yeah. So how galaxies stay together is the mutual gravity of everything else the galaxy is made of, plus this fun little thing called dark matter, which we don't know what it is yet. And that is a very fun mystery that we're still yet to figure out.
Missing matter. That's everywhere around us.
Yep.
I mean, I'm pretty sure we have questions on that, like, to come later. Like, what do we not know? And we're trying to figure it out. But maybe that's like an endless question when it comes to astrophysics, because there's just so much out there. I've watched obviously a bunch of videos and like you've been doing a lot on black holes. Is that, like something that you're particularly researching, for example, at Swinburne at the moment? Like, what are you really going deep on right now?
This episode is brought to you by Field. 1 in 4 business owners struggle with missed appointments, payment issues, and managing their team. Field fixes this with automation, marketing tools, and all-in-one payment solutions, helping businesses run smoother and even generate passive income. Know a business that could be doing more? Visit field.co, spelled FIELDD.co, to get started for free or chat with their team today.
Yeah, so part of my 2 day jobs that I have, the one being Kirsten is one, and then I also work at Swinburne University, specifically under the ARC Centre of Excellence for Gravitational Wave Discovery in Australia. So this is a particular research centre that looks into essentially black holes, all things black holes, a few other areas of space and astronomy too, but it's very much focused on gravitational waves, which are formed when 2 black holes smush together and ripples through space. So black holes is definitely a very key part of my work there. There are lots of really, really intelligent people looking at different aspects of black holes in the universe that do this really great research. And then I get the privilege of being able to translate that so that everyone else can understand it too. So that's where my obsession of black holes comes from. I get to basically yap about space with all these really cool scientists.
Well, I actually have a great transition from black holes here, which is I have a question around where does our understanding of the universe start to break down? And I guess I think about black holes and I think about that incredibly dense matter. Yeah, I guess is there a clear defined point at which we begin to lose track of how things kind of work, or is it a little bit ambiguous as to where that line is?
It might be a little ambiguous, but I want to say that it's a very clear line at the event horizon, which is the point of no return of black holes. That's where physics kind of we don't really have the physics to explain what happens within the event horizon. So what is an event horizon, first of all? When you have a black hole, or any mass really, and you squish it down so far that the gravity created by that is so strong that not even light can escape, you get this point, this surface, like a surface of a ball, where if you go within that surface, you have to travel faster than light to escape the gravitational pull of that object. That's essentially what a black hole is. It's just mass squished down so much that gravity is so strong that not even light can escape if it gets too close. So once you go beyond the event horizon, time, and that doesn't really exist anymore. Length, mass, it all kind of breaks down. There are some really interesting things about black holes like Hawking radiation, where black holes may evaporate because of quantum mechanics happening near the event horizon. That goes well beyond my understanding of the universe. I love astrophysics, quantum, and particle physics. During my undergrad, I did a particle physics course. I left the final exam in tears. I didn't remember that.
That can't be for everyone. So I have a quick follow-up question to that. And that is, so if the event horizon is definitely a clear line in the sand for you where we start to lose understanding, is that because our model of physics with quantum and classical physics don't meld together and we don't understand things, I guess, from a theoretical side? Or is that more to do with it's something that's not really observable because one, they're black holes, and two, they're far away, and it's hard to do things with.
I can see both being a reasonable answer to that question. The fact that classical mechanics and quantum mechanics don't really have an overlap yet. We're still figuring that out. Whether that will be figured out, I'm not sure. Again, much more intelligent people in that area of science are working on that as we speak. I will start crying if I stay any closer, so we'll just leave that. But then also, yes, there's just such extreme physics happening as you get closer and closer to a black hole that things just start to break down. And once you go beyond that event horizon, there's no coming back. There's no information coming out of that. Information itself when you cross the event horizon. There's a theorem called the no hair theorem, where like black holes have no hair, which is so funny because like it's a black hole. What do you mean it has hair? How could it even have hair? What is hair in physics? It's basically information. So a black hole itself doesn't really have information about what the star was beforehand. We can infer things based on what sort of stars should leave behind certain mass black holes. But other than that, there's no information, no hair, no information, because once it goes beyond the black hole, essentially destroyed. But I would be careful about saying destroyed because in the universe, energy can't be created nor destroyed, just transformed.
Oh my God.
Yeah. Not easily observable.
Exactly.
Yeah.
Well, speaking of not easily observable, I mean, you've mentioned a couple of things, like even dark matter, for example. But what is something that maybe you are working on at the moment, or like it's just has piqued your interest, that genuinely excites you because we don't know an answer to it yet? Like, what is something that actively we're working towards, but we just don't really know what's going to happen in terms of a concept in astrophysics?
Okay, so there's definitely dark matter is one of those things, but I'm going to step that aside for a moment because there's a new mystery that has been plaguing my mind recently in conversations I've had with some of the researchers at the university. And it's the mystery of little red dots. James Webb Space Telescope, JWST, it launched and has started getting some fantastic images of space and really deep images of space as well, because it's got a really big mirror, it's 6 meters wide, and it looks in infrared light, which the longer the wavelength of light, so with infrared, it's redder than red, it has a bit more longevity in the universe. It can travel through dust and stuff like that. Mm-hmm. So with that bigger eyeball collecting a different type of light, it can see really far away in the universe.
Yeah.
And what it did, and it looked at these deepest images, it kept seeing these little red dots.
Okay.
Right? Literally little red dots in the images. And we're like, wow, we've not seen them before. What are you? What is this? And the jury's still out on what it might be, which is really interesting. It could be black holes. It could be something else entirely. But that is a big new mystery that's been plaguing my mind recently.
And sorry, so this is like something really, really, really far out.
Mm-hmm. Okay. They only seem to exist in a certain time period of the universe, because when we're looking away, we're also looking back in time, right?
Yeah.
Only observed in this little pocket of time. We're like, why are you there? Why only there? What are you? So many questions.
So sorry, this is blowing my mind. Like in this period of time, meaning like right now we're looking back X amount of years, even if that's the metric, like way out into space. And then say in Earth years, we're looking in 5 years, you're saying they might not be there because of like
No. So we're looking away from the universe. Away from Earth, further back in the universe, further away, further back in time.
Yeah.
So when we look 10 billion light years away, we're seeing the universe as it was 10 billion years ago. Mm-hmm. And then 12 billion light years away, we're seeing as it was 12 billion years ago. And I'm not sure if these are the exact numbers, but let's just say those are the numbers for now. That's where the little red dots seem to appear in time, because we're looking that far away. So it's like they only exist there, and they're not continuing through the timeline of the universe as we're looking closer and closer to us. We're like,
wow.
See, you get it, right?
Yeah.
Why are you there? They're only there in the universe.
What happened?
For listeners who are just on audio, Kush is just like very blank faced, very surprised.
Yeah. Mind blown.
I actually do want to switch gears here. Again, on the trajectory of discovery, but a little bit different. a lot of people would have seen all this news about Artemis 2, these missions that NASA's doing. And I kind of just want to pick your brain a little bit and maybe try and distill it down to the average person who, they're getting distracted by the noise and they just want to know what is actually going on. So I guess I have two quick questions and then maybe like a couple of follow-up ones. I guess, what is the main goal of Artemis 2? Like, what is NASA actually trying to achieve? Mm-hmm. And like, why is the mission important if they're not landing on the moon?
Oh, two very good questions. So to the first one, what's the point of Artemis 2? So Artemis 2 is essentially to test human spaceflight going beyond the moon with new technology that we have since the Apollo era. So it's testing how the astronauts were in that spacecraft, traveling for 10 days together, going really far away, be further than any other astronaut has done before. So they broke that record made in the Apollo era for the furthest humans from Earth. And this kind of gives context by thinking about Artemis 1. So Artemis 1, that mission, did the same thing just without humans. So that was testing the engineering and all of the systems on board to make that trip. And then with Artemis 2, we add a little bit of extra complexity by adding humans and seeing how that goes. The next missions, Artemis 3, they've changed up things a little bit, but Artemis 3 will be testing how the docking and undocking will happen. So when you send things up into space, especially for moon missions like this happened in the Apollo era as well, is they sent up a command module and a lunar module. So the command module kind of has everyone in it. The lunar module goes to the moon, hence lunar. So they want, in Artemis 3, they're going to test breaking that apart intentionally and then docking back together in the low Earth orbit environment. So closer to home, less risk, so to speak, being closer to home, but testing that next stage of the next mission, which then Artemis 4, we will see humans walk on the moon again. Fingers crossed. That's the plan.
Wow.
Whoa.
That was such a good explanation.
We're testing each different stage, making sure, okay, cool, it worked this time, let's add more. Okay, that worked, let's add a different element. And we're doing that. And we did that with the Apollo era as well. So we'll start with Apollo 8. Apollo 8 was the mission that had the first humans go around the moon. And then Apollo 10, I actually don't know what happened with Apollo 9. Someone else can tell me. But Apollo 10 was the one before Apollo 11 where they went around to the moon, separated from the command module and practiced going down to the moon, didn't land on the moon, and then came back and went back together and back down to Earth. And then finally for Apollo 11, did the full thing. Walked on the moon.
Wow.
Awesome. Now, another little quick question on that is, and I know you're not an astronaut, but I know a lot of people have asked, maybe a little bit tongue-in-cheek as a joke, but what are astronauts actually doing on the flight? Because it seems very automated.
I mean, there is a lot of science that's being done on the mission as well. So yes, there's a lot of automation when it comes to the flight path. Like that has been planned out for years and refined in the months leading up and probably the years leading up to the launch itself. But the astronauts themselves, they're doing really important science, really important research and taking photos for us. But what's awesome is that you can watch them do their entire mission. Like there is over 200 hours of live stream data, video footage of them just doing their work in the International Space Station. You can watch them too, but in the command module and in the service module, you can watch them do their work. It's great. This mission was so accessible. Like I watched the launch while on the tram.
Yeah, it was streamed on so many places.
They streamed it on everything. It was on YouTube. It was on Twitch. It was really accessible. That was very cool.
And then hopefully, if we ever need, we're building towards Artemis. I don't know what number it would be but I got to ask because of Project Hail Mary. We'll one day be able to do that and save the whole of the galaxy, right?
We're just taking a quick break. We'd love it if you did us a favor and gave us a 5-star review on your podcast streaming player. We'd really appreciate it.
I mean, hopefully. I think the next plan after Artemis is to then continue to the Mars.
Yep.
So from Moon to Mars, that seems to be the current trajectory.
Okay.
And do a Matt Damon, The Martian.
Take your potatoes.
Get set up.
So cool. I'm gonna jump into, I guess, like just thinking about science as a concept, like turning to your science communicator brain. For someone not in science, why should people care about astrophysics?
Ooh, that's a very good question, because on the surface, it can look like we're all just pretty stars. Things happening up there. What's like curiosity in itself is a great driver, but it doesn't make sense to everyone, because if you're not curious about it, then it just won't make sense to you. And that's okay.
Mm-hmm.
That is okay. When it comes to astrophysics research, there is a lot of things that we learn from astrophysics that we can apply back here on Earth. So some things, for example, we have satellites looking up into space. We can turn those satellites back down to Earth and use them to monitor our Earth to understand more about how water flows across our planet, help with fixing or restoring after bushfires and wildfires. There's I actually made a video today, which is why it's on my brain, about this mission called the Landsat mission. So this is something that's been going on since the 70s. So it's like a 50-year-long mission where we've had constant surveillance of the Earth, watching it evolve and change in real time. And that has been really great, not just for understanding more about our Earth and our planet, but it's been a really good economic advantage as well. Like the economic benefit of the Landsat mission just in 2023 was $25 billion.
Wow.
And it only costs $1 billion to send a satellite up to space and monitor it for this particular mission. So in 2023 alone, it basically gave back a return on investment like 8 times over. So
crazy.
That itself as an economic benefit, huge. Also, you can go to your name in Landsat and you can have your name written out with letters in the Earth.
I did see.
So cool.
I saw that video today. That was so interesting. I'm going to try it for sure.
So there's little silly things like that as well. It's like, how could you not feel like that's cool?
That's so worth it.
Yeah. But then there's also that economic benefit as well. But even with things like the Apollo era, the Apollo era gave us Velcro.
Oh, yeah. Yeah.
Velcro came from space.
Yeah.
If you like hair tools, the ceramics used in hair tools like hair straighteners and curlers, that is NASA technology. Even Prada is helping create spacesuits. So there's fashion in space as well.
There you go.
Like there are so many different avenues where space research can coalesce and intertwine with other things here on Earth. Benefits lots of people, not just us nerds who are really curious about the universe.
I have a question more about thinking, but the same kind of idea about how that is kind of beneficial to everyday people. So I'm a computer scientist, and I found that, spending so much time like coding and dealing with kind of these different problems, I really have a very like mental model kind of structured approach to things now. And it's really interesting that I found the way that I think has changed. And I guess our question to you would be like, how has your approach to problems and decisions changed becoming a doctor and just being so educated on astrophysics? Have you found anything that really has influenced you?
I definitely think I'm more logical or follow certain processes when trying to make a decision or be informed about something. But then there are times where I'm like, oh, I'm silly. I'm silly. For example, when I go to the gym and use like the cable machines, you can put a little pin in the weight, and then there are like extra things you can bring down to bring up the weight between 2 plates. One of the ones at my gym has 0.625 as the additional weight. I'm like, I can't do that math. I need a calculator to do math like that.
That's so fair.
Yeah, it's just, we're all human, and there are so many things that we do. And I think that's what makes it kind of fun and humanizing. Like, yeah, sure, I have a doctorate, but I can't do math sometimes, and that's fine.
Yeah. I bet you're not the only person.
Does working in this field, and obviously there's lots of things that you're working out and probably lots of imperfect conditions and dealing with a lot of unknowns. Has that helped you deal with, I guess, just uncertainty in life? Or like, how does that like thinking or like just way of operating affect your day to day?
I think it makes me a little bit more adaptable in certain times. Again, very much human. If I'm tired, I'm very much not adaptable. But yeah, I think realizing, okay, cool, that's what's happening. That's the evidence for that. I can understand that. I can explain that, move on and move on to the next thing. I think that is what I find works well for me in the time of uncertainty is like, okay, I can try to explain this given the information that I have at hand.
That's a very fair response. Yeah, that's so true. We're getting towards, the end of our episode. And my question is around, is there something that's kind of about the universe or something that you've learned, or even just like a question that you've had that you just think more people should think about?
What I hope people would think more about is actually the process of science and how long science can actually take. So there is some small minority who are also a loud minority who are like, okay, say NASA releases an image of something and they say in the information, this photo was captured like 2 years ago. Or actually, no, there was a real example that's come into my head. We found the best evidence yet for signs of life maybe on Mars. And when this all came out, it was very exciting. When this all came out, the details are that the Perseverance rover looked at this particular rock and created samples and got information 2 years before the announcement. And people were like, why didn't they tell us for 2 years? I'm like, well, because we had to do science first. We had to figure out this is what the conclusion was and then write the papers and make sure that those papers go through the due process of peer review and have people in the field read that research, give critical feedback on that. And if reviewer 2 is a bit mean, then sometimes it takes longer to review that research and review that feedback. So I hope people think more about the process of science. Think of it like baking a cake. You have to prepare your ingredients. You have to then mix them all together and then wait for the cake to be baked. Then you have to wait for the cake to cool down if you want to put icing on top and make it look pretty. So that's what I hope people think more about.
That's so cool. It's like the curiosity in the process. Like you can't just like it's not instant. And maybe that's something that we're learning with. Oh, that's something that we have to challenge ourselves with in an age of AI where you can put in a question and like everything just comes instantly.
Yeah, like everything has become so now with things like AI, with social media, like especially things like TikTok and Reels, like you can just swipe to the next thing so quickly and get information so quickly. We kind of forget, okay, no, there's actually still a process to improve our knowledge and understand more. And even from a personal level, if you're trying to learn a new skill, that takes time as well.
Yeah, 100%.
Yeah, 100%.
In that spirit of curiosity and learning and getting into the process and getting into that mindset, if someone wanted to engage more with space or big scientific ideas, where do you think they should start?
Oh, where's the best place to go to engage with scientific ideas? If I may shamelessly say, Astro Kirsten on TikTok, Instagram, YouTube, your favorite social medias, I absolutely will say that.
You definitely may.
But if you also like your content in like word form, there are lots of really great writers and science writers who are writing articles about the latest research on places like Science Alert is one of my favorites to go to, with learning all about different science disciplines and what's happening in the field there. Space.com is also a great one for space-related specific things. But yeah, there's plenty of places to go. Just find what works best for you and engage with space because it's fun.
I love that.
Now, Dr. Kirsten Banks, if there was one thing about this whole discussion, this 40-minute discussion so far, that you could kind of leave as a key takeaway for any listener, is there something that stands out to you?
Well, without being a bit cheesy, it's to be curious.
That's perfect for us.
When it comes to the universe and it comes to everyday life, it makes life easier when you're just following your curiosity and finding things that bring you joy through that curiosity as well, whether it's black holes or dark matter or stars like our sun or planets. Just enjoy it and enjoy that curious process as well.
That has been my favorite takeaway yet.
Yeah, 100%. You're the best ambassador for the podcast and what we're about. But my favorite last question. Now, you've obviously done some epic work. Dr. Kirsten Banks, you're a science communicator, you're an astrophysicist. A lot of people, look up to you and watch your what you do and are inspired. But our last question is, what do you want to be when you grow up?
What I want to be when I grow up hasn't changed too much over the last 10 years, but I want to be the person who people think of when they think of an astrophysicist. Because when I was wanting to be an astrophysicist when I was younger, I didn't see anyone like me in the field, which didn't bother me at the time because I was stubborn as all hell. When I said to my mum, I want to be an astrophysicist, she said, okay, what job can you get? I'm like, I don't care. I'm going to do it. I'm just going to study it anyway because it looks fun. But for a lot of young kids, if they don't see that opportunity in front of them as something that they can do, then they won't necessarily think of it as an option. And so I hope, that when people think of astrophysicist, I'm one of those people that they think of and they think, I can do it too.
That's so good. I love that takeaway. And I feel like you embody so much of what we are trying to do as well, the Curiosity Crisis. And I really appreciate you saying that as just, that the idea of when you see that the path is possible, it makes it much easier to pursue. But we just want to say thanks so much for joining us here on the podcast. And if there's anything you'd like to shout out, feel free. But thanks heaps for coming on.
My pleasure. You can find me at Kirsten on your favorite social media account. And I look forward to following your curiosity beyond the podcast.
Thanks so much. Thank you for listening.
Thank you.
Find us at thecuriositycrisis.com and Curiosity Crisis on Instagram. We're on all major streaming services, so you listen how you like. And a quick favor, if you got anything out of this, please send it to a friend. Your recommendation is worth a lot. Thanks, and catch you on the next episode.
Thanks for listening. Find us at thecuriositycrisis.com and Curiosity Crisis on Instagram. We're on all major streaming services, so you can listen how you like. We'd like to just ask a quick favor. If you could share this with a friend, your recommendation means a lot. Thanks, and we'll catch you in the next episode.